In this demo, we're going to proceed to generate a forcing file with time-dependent forcing. So again, I'm going to go in my edit directory, and I'm going to go into my ROMs NC files directory, and I'm going to open the files main fork.m, nc files fork, and so I'm going to enable at this point the time-dependent forcing. Okay. And I'm going to, use this time-dependent forcing for the Great North Pacific again. So I'm just going to execute this in a MATLAB window to begin with. So here's MATLAB, cd ROMs. I'm going to go in the same directory. I'm going to fire up MATLAB, and I'm going to execute this portion of code. Okay, so next, I'm going to skip the climatological or seasonal cycle forcing file, which we just did, and go to the time-dependent one. Okay, so I'm down here. So here this section starts if do time-dependent equal 1, which is what we set it to, then it's going to execute this section. Again, you can execute this as just a script by typing main underscore what is it called? Sorry, in the MATLAB window. You can just execute this whole script by just typing this, okay, and just executing. Or, like in this case, we're going to just step by step execute particular pieces of the script to get used to it. So the first thing that this script does is you select a period of years, for example, that you want to generate the forcing file. In this particular case, I picked 1997 to 1998. And in the Pacific, this was an El Nino year. There was an El Nino cycle, and so I'm interested in modeling this El Nino. And the next thing that I do is I convert this year, this time period, into the datenum MATLAB format for the string for the date, and I want to return both the day number, okay, and also the number of days of the mid-month associated with this time range. So in other words, I'm going to convert every single day of this during this period from 1997 to 1999 into a day number, okay, from a particular reference. And so in this case, if I do that, let's just do that so it's easier to visualize. Go in MATLAB and just execute this. So now if I do, for example, date string of this of the number of days in the datenum format, I basically get the whole period here. You can see, every day during the period that we selected, from 1997 and so forth. I also produce, when I do that, another array called datenum month, and this is basically the day of the middle of the month. And this could be handy if, for example, well, let's look at that if it worked. A month. And here you see it's only giving you the mid-month day, so it's December 15, November, etc. And this is because now when we produce the forcing, we will going to choose whether we want daily forcing. In this case, this will be our calendar, or if we want monthly average forcing. In this case, the calendar is going to be the middle of the month. Okay, so that's we just produce both of them to have them handy. So next thing is we have to choose here if the forcing file is going to be daily averages, for example, or monthly averages, for this particular routine. And so if we decide for daily average, then we're going to use datenum days, okay. If we decide for the monthly average, we're going to choose datenum month. So here I'm going to pick, for example, the monthly averages because it's quicker to do, and I'm going to just execute this statement over here. And so if you were to generate a script that does all that, what you would do here, you would simply comment this out like that, okay? The next thing, we're going to focus now first on wind stresses, and in particular we're going to focus on extracting the ncep reanalysis wind stresses. So in order to do that, we have to now create an empty file with the right characteristic, and as similar as what we did in the previous example, we're going to define here the SMS time, which is the length of the time records, and so this is really just given by the length of IDN vol, which is basically defined over here, which is how many months there is in this time period from 1999 to sorry, from 1997 to 1999 over the range period. Then we're going to also say here that the SMS time cycle is going to be equal to 0, which means that this is not a periodic forcing, but it's just going to be a one realization of the forcing over the period defined in our period range. And then we're going to say that the time value of time val, which is the values, the actual values in days of the forcing field, is going to be equal to IDN val, which is what we did here in this date no MATLAB format. Now the date no MATLAB format is one that we could use with ROMs in that it's in days, and as long as you have this precise forcing associated with each day, then you can use any kind of reference day that you want to produce the ROMs model output, as long as you know which reference you use. In this case, we use the date no MATLAB reference point. Okay, so then just for simplicity, I'm going to assign this this date, if you like, to this array called myDate, which I'm going to later use. And then I'm going to create a name for the forcing file, and I'm going to put together this name here by using creating a string that is like the first year towards the last year, and and then I'm just going to have a fork file, which is the name of the file. So I'm just going to execute this in MATLAB. And so fork file now, just to show you what it does, it's basically the name. I've put together a name of the forcing, which has the initial and final year, which are given by this strn array here that has num, year 1, year n is basically string. Okay, once I have a name defined, then I can create this file with the specifics contained in opt, in this option array. And so as similar as we did for the seasonal cycle, I'm just going to create this empty file. Then I can do ls minus rtla, and you'll find that this empty file now is right here. And once again, as we did before, we can check the content of this file. And in this case, it only has two forcing fields, because we're only creating the U and V stresses. And this is done because if you look back in the option array, you see that the option array only has the SMS time, which is the time value for the U and V stresses, but doesn't have the variables associated with all the other forcing fields. And so when we create the file, then it only creates the file for the V and U stresses, which is good. And if we go further down, we have here in SMS time, we have the days, okay, of the forcing, and these are this MATLAB convention, the date num. So you can see that these are spaced of about 30 days apart, which is monthly averages. And then the SU, STR, and SV, STR arrays are empty right now. Okay. Now once again, the option array is defined like this, and this is different. You see it has, the length, the cycle is 0, and so forth. Okay. So at this point, the next step is for us to extract, the actual forcing. And we're going to begin by extracting the ncep reanalysis. The ncep reanalysis goes from 1950 to 2005. And you can extract from this data set either the climatology, which is the monthly mean climatology, the seasonal cycle, which is what we did before, or you can extract monthly averages, time-dependent monthly averages, or time-dependent daily averages for the period of interest. Now the way you do that is first you define a date array, which is the time that you use in this convention. This is SMS time val, which is the time that we gave it here, IDN val, which is dates num, which is basically the it's the 15th of every month from 1997 to 1999. And then so we give the longitudes, the latitudes, the date that we want to extract. The forcing type. This forcing type was defined over here, where we said the forcing type was monthly. Okay, so by doing that, this is going to extract the monthly averages. And then you tell the arrays that you want to extract, in this case just the U and V component of the stress. If you remember, before we used the same function where we had also here more, we had more values, in that we had the forcing variables also for the heat fluxes and so forth. But in this case, we only want to extract the wind stresses. So we can execute this part here in MATLAB. And you can see that now it's extracting 1997 U and V, 1998 U and V, 1999 U and V, and now it's fitting the NaN values for the LAN mask. And if I now tap fork D, I have here my win stresses, which are in the ncep grid, on that portion of the ncep grid that covers the model grid, in this case the North Pacific. Now once we have this fork D array, then our next step is to just interpolate this to the actual model grid and save it in the netcdf file. So I'm just going to go further down here and skip these other extractions programs, which are to extract different types of data sets. In this particular case, this would be the QuickScat wins, and this would be the QuickScat ncep blend. And you can extract some of these other products. The QuickScat is a satellite product, and however, the QuickScat only starts from 2000 to 2004. Whether this other product, the QuickScat ncep blend, is from 2000 to 2008. So of course you would only have to use periods. You could only extract forcing over that period. So we go further down, and at this point we just save all this stuff into the forcing file. So first we create the CTLF, or control array, for the forcing file by doing that. And then we go back here and we just use the interp to grid ncep to interpolate the fork D array, which we just produced, into this file that is defined by the CTLF array here, and which is on the grid GRT. So that's the call. And so let's go in MATLAB here and let's execute that. And now it's just, as you see, is saving basically the U and V component everywhere. And at this point, if we do an NC dump of this, we go further down and we have that all the SUSTR and SVSTR files are complete. In fact, we can load, for example, the SUSTR RNT load var and CTLF, and we're going to load, for example, from 1 to 36 months, which is the entire period, and we're going to extract the zonal component. And then we're going to plot this just to look how it looks on our grid. So this is the North Pacific grid, and we're going to say RNT PLCM, and then it's going to be mean of SUSTR comma 3 comma and then on the grid GRD. And what we see is what we expect. This is the North Pacific, and so here you have these zonal winds that are directed towards the west. Sorry, towards the west. Sorry, towards the east. And in the equator, we have the trade winds component that is more directed towards the west. Okay, so this makes a lot of sense. This is you may have learned this in an oceanographic class. This is a typical structure of the winds in the northern hemisphere. And so this basically concludes this extraction of time-dependent forcing. Just to show you that this thing is very easy customizable, we can go back here and say we wanted to do a QuickScat satellite winds for the period, say only from let's say 2001, okay, just for fun. So we just have here, we put year 2001, okay. So we could just go back here, do the same kind of thing up to here. We go to MATLAB, we produce that, and we go back to edit here, and then we can just extract the QuickScat this time. For example, let's go in MATLAB, and okay, this is an error that I'm going to have to fix. And it has to do with the fact that this particular utility HDSF is not been properly installed on the cluster right now. So we'll take care of that in a different tutorial. So this concludes our tutorial for now.